last speaker before lunch, we have Gurvinder Singh Khinda from HealthCare. We'll be talking about sustainability in single-use medical sensing.
Hello, everyone. Thanks for the invitation again, and thanks for joining this talk. So overall focus of this talk will be the current project we are doing funded by NextFlex. It's more about what are the possibilities around the materials and processes, what we are looking into to be a more sustainable device, especially for the single-use devices also, like with the wearable electronics and everything. And what is our perspective and how we can go as a community also with all the inputs to go take it more further. So there was an initiative from NextFlex. This is 1.5 years ago with the project called 7.7, where we look at the manufacturing approaches for low-cost, sustainable, single-use medical devices. And we approached this problem in a way that to address both cost and sustainability issue through using our flexible hybrid electronics manufacturing, checking what materials are out there so we can replace the current more precious materials around to get a more sustainable device. And then also some environment conscious design practice also. Either it can be using the right processes, manufacturing sites, or right materials, or any type of modification in the designs also, what we can do. Or also thinking about in a sense of that, like we are making now conventional devices with the standard processes, which can be used for multiple use. But if it is a single use, how much you want to over-engineer that device also, right? So that at the end it can't be recyclable, it can be recyclable, the perspective of it. And then other methodologies like we look into was the life cycle assessment of it. So at the bottom left, we put like a roadmap to see where we are. At the bottom, you can see a copper flex, and with the hybrid electronics, you can make it more sustainable. But again, we are using like silver rings, gold rings to make all these electronic devices. So what are the alternatives to check the processes and materials? And again, on the right is like some literature how we can go from a fossil-based device to a more biodegradable device or bio-based device, with making it more sustainable. The research what people are doing. So just introduction to the team. So this is a project led by HealthCare. Binghamton University was administrative lead on it. We have teams from Infinite Corridor, which is providing the electronics to us. Their vital sign monitoring patch. Tapecon is our manufacturing partner. NextFlex is our advisory on how to make the conventional electronics into a more hybrid, printed hybrid electronics device. And then we have our environment conscious design advisor council also, Arship Global, who is helping us for doing the life cycle assessment of these devices. So for this problem, we took two problems. One was the single-use electrolyte sets, and we see how we are manufacturing right now, like using a PET material, silver inks, using polymers for encapsulations, and see what are the alternatives to it, and do a manufacturing process around it to see is they are using them is a good option, are they working, and do a life cycle assessment. And again, second problem we did in the parallel that, okay, we have this conventional ECG monitoring, SpO2 monitoring device. Can we make it fully with the printed hybrid electronics technology? Is it a viability? What are the yield of it? What are the processes we need to do? And how after getting the devices is working, or then to check, okay, what will be the life cycle assessment of it? Is it like more environment conscious or not? So starting with the first problem, that is majorly I'm going to talk about in this talk. Binghamton University students went back and looked all the alternative materials around the conductors, substrate, and encapsulations, and check all the materials around from processing with the set of requirements for processing, for their impedance, conductivity, their performance parameters, and the reliability parameters. They come up with the different inks. We focused from silver to carbon inks for our conductors and the shield layers, and then paper type substrate. First thing we came into our mind, okay, how we can replace a PET substrate everybody comes around, like